Welcome to IDSKT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
In the modern battlefield of counter-terrorism, one of the most powerful weapons isn't a drone or an elite strike team, it's DNA. Forensic DNA technology, once used mainly to solve cold case murders, is now quietly revolutionizing the hunt for terror suspects. Today, the most reliable witness in a terrorism investigation may not be a person at all, but the invisible genetic traces we all leave behind. Every skin cell, every stray hair, every grain of dust can tell a story. And that story might be the thread that unravels an entire terror network. Whether it's a smudge on a weapon or the dust on a suspect's boot, forensic science is now providing authorities with a molecular map of the truth. At the core of this transformation is genetic fingerprinting, also known as DNA profiling. It relies on analyzing tiny, variable regions of our genome known as short tandem repeats, or STRs. These markers create a unique DNA profile for each person. From a blood droplet or a fleck of saliva, experts can now generate an identity with stunning accuracy. And they're doing it faster than ever. With rapid DNA analysis, what once took days now takes under 2 hours even in the field. After the 2023 Miami bombing, over 200 biological samples were processed within 48 hours using rapid DNA units. That kind of speed can mean the difference between stopping a second attack or missing the next move. But the frontier is shifting beyond blood and hair. Enter environmental DNA, eDNA, where investigators extract genetic material from dust, soil, even the air. A speck of dirt on a jacket or luggage can now be analyzed to reveal where someone has been and who they've interacted with. Thanks to advanced tools like next-generation sequencing, authorities can trace suspects' movements across borders and link them to terror cells with chilling precision. Australian scientists, for instance, have pioneered techniques to track suspects based on the unique DNA profile of dust found on personal items. This can even map where the dust came from, whether it's a specific training camp, a war zone, or a safe house halfway across the world. Globally, Interpol is turning this science into intelligence. Its DNA gateway holds over 280,000 profiles, allowing countries to share genetic data anonymously and securely. Real-time alerts, kinship matching, and cross-border collaboration now help law enforcement catch suspects they never even knew were connected. Take West Africa, where DNA technology is empowering countries like Nigeria to investigate terrorism based on science, not just confessions. DNA has confirmed links between insurgent attacks, tracked explosive devices, and brought justice to victims of sexual violence. Still, the technology isn't without its risks. DNA doesn't lie, but how it's collected, stored, and used can raise ethical questions. What happens when innocent family members are swept into investigations? Or when AI models misinterpret complex genetic data? As forensic tools grow more powerful with facial reconstruction from DNA, predictive behavior models, and blockchain-secured evidence chains, we're entering a new age. One where every contact leaves a trace, and even the faintest biological signature could expose a terrorist plot. The challenge now is not just to unlock the truth, but to make sure it's used responsibly. In this high-stakes domain, science and ethics must evolve hand in hand. Because in the war against terror, it may not be the loudest voices, but the silent witness of DNA that tells the story the world needs to hear.